Hello, everyone. D. Alfred Ostrowski here, Theory of Computation. This is a series of theory of computation discussions, and this is lecture 8, for lack of a better term. And in this recording, I'm going to be covering Greibach normal form. Most importantly, why are we interested in learning this at all? Greibach normal form, as well as Chomsky normal form, are two means of standardizing our grammars. And by this point, I'm sure you have an appreciation that grammars are extremely powerful. And if you tried to program them, okay, trying to take a grammar-based representation and actually implement that, whether it be in a compiler, some kind of type of natural language processing, or emulate some type of generative AI, okay, which has become, it's been exploding this year. In the actual practical application of this, it is imperative to appreciate the fact that these normal forms allow for a level of efficiency and consistency in implementation. So that is their utility, and I bring that up as a means of motivation that is just, this is more than just a theoretical exercise. Secondly, moving on to, let's say, an understanding of context-sensitive grammars and unrestricted grammars. The more manipulations we work with our grammars, the better appreciation of what they are and how they are leveraged and how they fit into the grand scheme of things. So without further ado, let me work through a small example of conversion to Greibach normal form. We don't want to work through large examples because there's not a lot to be obtained from doing a very expensive example. It is very error prone because there's a lot of substitutions, and it could be easy to make a simple mistake. But the whole idea is to understand the approach and the steps that we're going through. And if you haven't listened to the prior lecture, lecture 7, I talked about the elimination of left recursion. So I broke that out. So at this point, hopefully you went through a couple exercises to have an appreciation of how to, what left recursion is, why we want to eliminate it, and how to do that in a few simple steps and verify that you've done it appropriately. And now that we have gotten that out of the way, then we can work through stepping into the Greibach normal form. Also, if you haven't listened to lecture 6, you might want to look at that as well. So lecture 6 looks at Chomsky normal form, and Chomsky normal form is the starting point for the Greibach normal form, right? So I'm not going to go through that. I'm going to assuming that we're starting with Chomsky normal form. Again, we're breaking the problem down and just looking at the most simplest examples here. So we can understand what's going on and not really being bogged down with a lot of expansive examples that really don't go too far to proving the point here that we want to represent. So what is, just in review, the Chomsky normal form says what? Chomsky normal form says I'm going to have a grammar with a representation of either two non-terminals or a single terminal. It could be together in the same role or separate roles, and so on and so forth. But that's what we are, that's our starting point for the conversion that we're going to be assuming here for the Greibach normal form. And the Greibach normal form is going to be a terminal followed by any number of non-terminals. Must be non-terminals, so it can't be intermixed. It's got to be a single terminal followed by, on the left-hand side, followed by non-terminals. Could also have just a single terminal as well. So in generic form, that's our starting point with the Chomsky normal form, and we're interested here is Greibach normal form. And let me kind of outline the steps. And again, this is not to be a reference guide, this is more of a conversational user guide approach, right, to solving the Greibach normal form. So I'm not going to be going in great detail just going to be pointing out the basic steps here. So if I want to summarize the steps, I'm going to start off with Chomsky normal form. Again, if you don't know what that is, go back and take a look at my recordings or any other sources. The next, I want to relabel. Okay, I want to relabel my non-terminals. Okay, and this is so they'll be in incremental order. What that is, I'll go through that when we get to that. So, sorry about my writing here. This isn't writing as well as I expected it to be. Then I want to, through the means of substitutions, I want to realign, for lack of a better term. Okay, my grammars. So it is in incrementing order. Okay, so I have A of an I, and it goes to A of a J. It's really the first that is the most important, but J has to be greater than I. Okay, so that's going to drive what we're doing in the process. We're going to be doing also eliminating left recursion. Okay, and then any substitutions as necessary. Okay, and this is to support this representation. So, and at this point, and this is going to strengthen your understanding, right, that the substitution is going to definitely give you, the more that you work with the grammars, the more comfort level you're going to have with how the substitutions work here. And that takes us to Greibach. So let me clean the slate here, and we're going to take the simplest example that I can find and work through it. So I have a grammar again. I'm going to assume, for brevity, I'm going to assume Chomsky normal form. And I have two rules, non-terminal A, non-terminal B. Non-terminal A goes to A, non-terminal B, terminal A, and non-terminal A, B, terminal B, respectively, right? And this already satisfies my first step. It's in Chomsky normal form. So I want to relabel these, right? I want to add numbers to these. One thing I want to make sure and not make any simple mistakes is I don't want to add labels when they're not necessary, right? If I have a B, if I label B, where I'm going to use B further on, I'm going to use obviously the same label. So I'm not going to assign more than one label to a non-terminal. So I'm going to label these all A. I'm going to add subscripts for each of them. I'm going to take A, I'm going to relabel that as A1. And I'm going to say B, I'm going to call that A subscript 2. And I have another B. And just towards my point, I'm going to label that as A subscript 2 again. So that's my newly defined first rule. And then for the B, I'm going to call that A subscript 2 because I've named that already, right? And then I'm going to, my A was labeled as A1 and the B is A2. So I don't have to, again, I'm not going to recreate any names for something that's already been renamed. And I'm going to incrementally, from top to bottom, label that. So that was the step 2. Okay. That was 2. This was the 1. And now with the 3, I'm going to realign this. Okay, I'm going to reorder this through means of substitution. I know that with any of these non-terminals, I can replace that, but I have to replace it with the entire rule, right? So let's look at it from incrementing, right? From left to right. Most importantly, from the left-hand side, usually references a subscript I to the right-hand side, starting with the first non-terminal of every production. And here I have 1 going to 2 and 2, and that's fine. Okay, I don't have to, I don't have to make any modifications here. What I do need to change is I have 2, A2 goes to A1. And here I is, J is less than I. Okay, so J should be greater than I as I'm moving towards the right. So this is fine through step 3 for the time being. But I need to address this. And that's what I'm going to do. And how I'm going to accomplish this is I'm going to substitute the A1 on top, which is going to all A2s and A's. And I have to consider the entire rule. So I'm going to substitute that for every position A. So I'm expanding my rule. That's why we get these rule expansions. So let me just copy A1 just again for consistency, A1, A2, A, and that doesn't, at least for now, it doesn't change, right? But the A2 does change. And I substitute the A2, A2. I'm sorry, that was a 2 there. Okay, so I'm going to substitute A2, A2. Let me erase this just to clean this up a little bit. Whoops, let me bump my font a little bit more here, or the thickness. There we go. A2, A2, that's substituted for the A1 there, and I keep the original A2, that was from here. Okay. But I also had an A here, right? So I'm going to put an A and A2. So when I replace 1, once again, I replace it with this production and this production. This was replaced here, and this was replaced here. So it can be a little confusing when you look in the book and boom, these productions expand and kind of lose the process here. But if you highlight or annotate it, then I think it makes a lot more sense to get the visualization of exactly how this should look, right? So what do I have left? I substitute everything in for A2, and I still need the B because the B is still in there. So this satisfies that next step. I want to be incrementing. Okay. Now I want to address the left recursion. And how would I accomplish that? So I can look at A2 here, and let's eliminate that left recursion. So what do I need to do? And this is a little more expansive than what I'm used to, but we can work through this, right? So here I'm taking I'm getting rid of this, right? This isn't going to exist, and I'm going to need to represent what's being recursed on the left. That's going to exist in my Z rule. So I'm continuing this up on the top here, right? So I'm going to start off the Z. It's going to have an A2 in that, right? In the past, we've only had a single, let's say, terminal, but it could be a non-terminal as well. That's fine. We're not done with Z. Look at the final representation here. So I'm going to have my A2 is going to have AA2Y because that doesn't change, and neither does the B, right? And now I'm going to add the Z. So as in the early examples of elimination of left recursion, if you haven't seen that or gone through that or have a comfort level with it, please go back and look at that. So I broke that down so this would be a little more palatable working through here. So here I can have A2Z and B of Z. Why? Because again, even with a single terminal, I can assume that I don't have, that I go directly to that terminal. And this exists as the functional equivalent. So in similar fashion, I made the push the recursion to the right, and this rule now stands as completely recursive. Here I have the A2. I'll just copy that. They're the A1. I'll copy that here, and I'm not gonna deal with that right now. I just want to eliminate it from here because this was the primary offender, right? So I'm gonna look at Z and just look at what Z was doing for us. So let's just look at a description, English description of any number of non-terminal A's. So non-terminal A, infinite number of non-terminal A's, right? Side by side, okay. And it gives this by itself, or I can recurse, in this case, recursing to the right. So in that case, I have a similar representation where it can exist by itself. And in the past, we've used terminals, but it can functionally exist as non-terminals in the same fashion, right? So just think that what I've circled here as being exactly the same, and I'm going to buy the right recursion by using the Z, right? So these two are set here for the time being, right? I've eliminated the left recursion and I have the A2. So the next steps, I want to take A2 and substitute this in appropriately, okay? So here I can take the A2 and I can shrink this, right? This was an A. And I can take the, make sure that I substitute everything appropriately here. It's the A1, so I can have A2. And how did I get that updated? I'm sorry, this is updated A1. This was A2, this was A1, right? And let me go here just to straighten that a little bit, right? That was my A1, and erase this. And this was my updated A2, right? Just in the same fashion. So how did I get from here to here, right? So I substituted A2, which has the BA2, BZA2, and this was these two substituted in here for this two, right? And then I had the AA2 and I believe in this one, I needed the A2 here, okay. And I'll follow up and correct that if I'm mistaken. So here I have the two substitutions in here. So I took all these and I substituted it into the A2, but I had to do 4 substitutions, 3, 4 for this. So this blew out to from 1 to 4. And that gave me, I'm sorry, once again, this is A1, not A2. So my confusion. Go here. That was wrong, but I made a mistake. Okay, so that was the A1. So the A1 were from here to here. And that is the substitution. So let's look at this, okay? Let's ask ourselves the hard question, okay? And this was the final means. This could be viewed as a step 4, right? Because I eliminated the left recursion, but I hadn't done the A1 was still not addressed. So the step 3 addressed this, the step 4 addressed this, right? Here I had to do, this was that rule of substitute when necessary, right? That I substituted until I got to my format. My format being, I wanted to go from Chomsky to Greibach, and Greibach must have a terminal, either by itself, followed by any number of non-terminals. And I have that here, and I have that here, and I also have to do a similar substitution for Z. And Z blows out in the same fashion. So this is going to turn into 8 rules, right? So I'm going to have 4 rules here and 4 rules here. Let me see if I can squeeze this in. I'm going to write out Z. So this is why we start with the smallest possible examples of Greibach, because this does get a little hairy. Okay, let me just erase a little bit here, and I'm going to write it out longhand. Hopefully you get the whole process here, right? I need Z to get my final Greibach representation, right? So that's going to be the final I have. A2, that's done. Okay, A1, that's done. But Z is not in the format, so I'm going to squeeze this in here. I'm going to put a little F for final here for the answer. Here, I'm going to address this, the A2, A2. I'm going to put A2, A2. I'm replacing this with this. B, A2. A2, Z, A2. And BZ, A2. What did I accomplish here? I addressed this, right? And then I have A2, A2, Z. So it's all this with a Z at the end of it. And then I'm going to be done. So I'm going to write in two rows because I'm running out of space here. And I don't want to start off with a new string because I want to have the whole mess. Okay. And again, this is why we don't have very expansive means of Greibach-based representation. So A2, A2Z, BA2Z, make sure I got this right. So it's the A2Z, not just Z, right? So, but I had that here. So it's this BA2Z, AA, Z, AA2, ZA2Z, and then finally BZA2Z. So there we go. I blew this out 4 times. I blew this out 4 times. Why? Because A2 had 4 representations, and I'm replacing A2 non-terminal with its actual representation, and this was in Greibach. So I put this in form here. I've eliminated left recursion. I put it in an appropriate format. I've done all the appropriate A2 substitutions, and here is my final Z, my final A1, and the final A2. So this was the final representation. This was the final, and this was the final. So there you have it. A little messy, but again, if you have the comfort level, you need the comfort level with 2 things, 3 things really. Elimination of left recursion, separate that out, get a comfort level with that. Comfort level with the substitutions. I think we already know we're going to have a comfort level with substitutions at this point. And then the 4 basic steps, Chomsky normal form to start off. numbering my non-terminals, okay, going from this type of representation to this, and then performing substitutions to make sure that my numbering is incrementing from left to right. I have a number of non-terminals, it doesn't matter, just the first non-terminal on the right-hand side has to be greater. And then eliminating left recursion, and then the final step is any continued substitutions as I adjust here to squeeze it back into that format. So thanks for listening. Hope this helps. Have any questions, let me know, and I'll try to get further examples out. Thank you. Take care. Bye now.